Sorry for the technical difficulties we've had this afternoon, but I'd like to begin session 4B. I'm Galen Baumgardner. I'll be the chair of this session. We will be beginning with our first speaker, Ms. Marimar Colas. She is the senior researcher at CEPSA Asphalt Team in Spain. She has 30 years of experience in bituminous binders, both bitumen and emulsions, and she's in charge of the new asphalt products development. She's a director of ATEB, the Technical Association for Bitumen Emulsions in Spain, and of the technical committee from 2010 as she has been the vice president of the IBEF, International Bitumen Emulsion Federation. With that, Ms. Colas is going to be presenting high performance recycling with bituminous emulsions, and I'll ask you to post your questions in so we can answer the questions at the end of her presentations. With that, we will begin the presentation from Marimar Colas.
Good morning to everyone. First of all, thanks to Technical Program Committee of 7th Eurobitume Congress for choosing this paper to be presented. The title of my presentation is High Performance Recycling with Bituminous Emulsion. This is the index of my presentation. I have only 10 minutes, so I talk mainly about aspects related to the materials, production, and performance of these mixes to end with some conclusion, but if you need more information, is on the paper. To start, what are we talking about? Well, high-performance recycling bituminous emulsion is a half-worn recycling, but using a modified bituminous emulsion, and that allows to use up to 100% wrap, heating it around 100 degrees. The mix could be stored for 24 hours, but after laying, it's possible open to traffic immediately because no need cooling time. The high performance recycled bituminous emulsion advantages are given by facilitating the moving a circular economy from linear economy and are specified in recycling up to 100%, greater durability and lower energy consumption and emissions. Respect to the materials, the constituent materials are the wrap, the aggregates, and of course, the modified bituminous emulsions. This emulsion is a slow setting modified cationic emulsion according EN 13808. And this emulsion provides 100% coating with no binder runoff, high resistance to thermal shock, high initial cohesion, high adhesivity, and high workability. Respect to the wrap characteristic, we have the typical or critical points. The gradation curve and the characteristics of the aggregates. We have some limitation according to the type of the mixture. The homogeneity of the wrap, the classification of this material in at least 2 fractions, taking into account that the smaller one will have a higher content of binder. We have to characterize the bitumen from wrap, at least with penetration and softening point, the moisture of the wrap, and is recommended to cover the wrap to keep the moisture in the proper one. According to the emulsion, we have this type of emulsion for this type of mixes, C60BP4. The specifications are included in standard 13808 and is the specification that we could see in the table. But this emulsion have CE marking, of course, and is produced with a polymer modified bitumen to improve cohesion and adhesivity. Respect to the production could be made using different types of plants. The first one is special plants designed for these half-worn mixes, but we could use also adapted standard asphalt plants for asphalt concrete. So we have a specific dryer barrel for wrap heating to avoid stickiness, an independent system for emulsion, and a vapor extractor of the mixture. For heating the wrap, we could use two methods. The first one is the direct one, and it is based on introducing the wrap through a ring far from flame and preserve the wrap characteristics. So in this case, we have to control the temperature of the wrap in all the process. The advantages of this direct method is that we could improve the mix between the old and new bitumen, and we could have the chance, to use more wrap content. Because with this direct method, we could use up to 100% of wrap material. Another method is the indirect one. This method is based on heating the wrap from an overheating of aggregates, but we have to take into account the limitation of 220 degrees and the maximum rate of wrap that we could use according the temperature of the wrap material and according the humidity of the wrap. In this case, the content, the rate of wrap could be close to 60%. Okay. Following with the quality control, we can use the same test method that for asphalt concrete, but adapting them for this type of half-worn mixes. We could use different system compaction, like impact or giratory, and we have to define the best condition according the wrap rate. For a better understanding of performances, new test methods as finish tests, cohesion tests, and cracking at low temperature could be proposed. Anyway, we need to continue working on it from worksite section to define the best test method for the quality control. In this slide, we have some result of two recycled mixes with different wrap rate and different performances, mainly according the modulus of rigidity and surface texture. As a summary, I would like to highlight 4 points. The first one is water sensibility. The results are close, the minimum for the hot mix asphalt specification. The modulus. The result depends on the wrap rate. In case of 80% of wrap, very similar to hot mix asphalt, but with lower wrap rate, we could be similar to cold mix asphalt because they are more flexible mixes. We have a very good initial cohesion after compaction, so we no need curing time, and we have the possibility to extocage the mixing and lying 24 hours after. So what is this good for? Of course, I think it's good for rehabilitation and new works construction, but also for wearing cores and binder cores for medium and low trafficked roads. Here we have some experience, some figures taking of some works carried out that illustrate moments of lines and machines. So the most important thing is, for the time being, more than 20,000 tons of recycled half-worn mixes were used, with more than 80% of wrap. Some works have 10 years old, and some of them have been used as surface layer. To finish, the conclusions are: high-performance recycling with bituminous emulsion have good performances thanks to the special emulsion we have used and we define for this technique. High-performance recycling bituminous emulsion is a good option according to sustainability and circular economy. And the use of polymer modified emulsion is interested to contemplate their use also for surface layer, for wearing course, where good resistance to reformation and better initial cohesion could be a requirement for high trafficked roads. I would like to thank to Benito Arnaud and Campezo for access to the information of half-worn recycled mixes manufactured in their plants and included in this paper. I would like to finish. Thank you for your attention, and I remain at your disposal for any question.
Thank you, Marimar. Very good presentation. We do have a couple of questions. The first question is, in your opinion, how far away are we from producing cold mix wrap systems that are suitable for surface course applications in regard to equivalent durability and longevity to hot mix?
Hello, Galen. Thank you for the question.
Sorry for all the difficulties.
Okay, can you hear me now?
Yes, yes.
Okay. Thank you for the question. I think we are closer than the previous year, of course, but we have to change our mind and to consider the use of cold mixes or half-worn mixes could be an option, or not only for using wrap, but also for using virgin aggregates. But I think we have good experience, and we are more and more interested in this type of measures according to sustainability and technically they are very, very good solutions.
And then the next question is, what type of polymer is used in the PME?
Okay, thank you for this question too. We produce a polymer modified emulsion using a blending of conventional bitumen and a polymer modified bitumen. Is a PMB 458065. So this is this blending is the binder that we have used for this emulsion.
Okay, thank you. And I'll apologize, Marimar, because I know you're confused. Actually, the questions and answers are going to be at the end of all the presentations. And I, with my frustration this morning and getting signed up, I started this wrong. So I'm going to go ahead and introduce the next presenter, and we'll continue with the program. Thank you, Marimar.
Okay, thank you.
Mm-hmm. Our next presentation is going to be Joël de Vescher. And Joël is a graduate of mechanical engineering from the University of Brussels in Belgium. She has a PhD in mechanical engineering since 1995 from the university. Since 2001, she has been in charge of research at the Belgium Road Research Center. She's the deputy head of the Division of Bituminous Applications and Chemistry at the Belgium Research Center. Her main research activities are in the field of asphalt mix design, asphalt performance testing, sustainable development in the asphalt sector. And her presentation today is going to be on European laboratory test methods for slurry surfacing revised in view of the field practice. With that, we'll begin the next presentation.
Good afternoon, ladies and gentlemen. I'm very happy to be here today and to speak on behalf of my colleagues who have been working together on a project called Better Performing Slurry Surfacings. I'm presenting this paper as project leader, so I hereby want to express my gratitude to the entire team, not forgetting, of course, our technical staff at BRRC. So when we speak of slurry surfacing, we mean both slurry seals and microsurfacing, two technologies which are not fundamentally different, except that microsurfacings provide more strength and stability because of the polymer modified emulsion and the optimized grading. Slurry surfacing is very sustainable, provided that it is applied on time and that the slurry mixtures are durable and will perform well for many years. And a key to good performance are reliable test methods, because as we all know, if you cannot measure it, you cannot improve it. After a brief introduction, we will sum up the main performance requirements of slurries and then discuss the related test methods to end with the conclusions. Slurries, as you probably know, are called mixtures of at least three components: mineral aggregate, bitumen, emulsion, and water. Very often there's also a small quantity of active filler, a dope to retard the breaking process, and possibly other additives like pigment for coloration or fibers for strengthening. The mix is prepared on site and then immediately spread, and usually after 1 hour the road can be reopened to traffic. The result is then a new and smooth surface with restored skid resistance, and by restoring the waterproofing, the underlying structure is also protected against further deterioration. So it's clear that preserving the condition of the road using such a cost-effective technology is on the long term much more sustainable than, for example, regular milling and repaving. So that's why BRRC dedicated a research project to slurry surfacing. And the scope of this project was in fact wider than just a lab study, but it also included monitoring of many work sites. And this very wide scope allowed us to better link the test results to field performance and also to better evaluate the relevance of the tests for mix design. But before moving to the tests, what is the performance that we require in case of slurry surfacings? First of all, quality and durability depend highly on the execution, and therefore the first requirements are a good consistency, which means that the mix is homogeneous and workable, and that you don't get any segregations or lumps in the mixture. And then also, once that the mixture is applied, the cohesion of the mix shall increase rapidly to a level which is high enough to withstand the forces exerted by traffic. And then once subjected to traffic, the performance requirements are on the left, a good resistance to wearing or raveling, resistance to bleeding, which is the phenomenon of an excess of binder appearing at the surface, and then also resistance to delamination. So where are we when it comes to test methods to measure these performance characteristics? As seen in this table, there already exists a number of European standards covering the three first and most important performance characteristics. There are also some alternative tests, like for cohesion, but for bleeding and delamination, there are no European test methods yet. So there we had to set up our own test methods. And for all of these tests, these are the issues we have investigated: the accuracy of the test conditions and procedures, especially the parts on mix and sample preparation, which needed further refinement, the repeatability in order to be able to evaluate test results, discrimination power, and then of course the link with field performance, and last but not least, what do we consider as good or acceptable results? And note that for this last point, we looked at the existing specifications of the ISA, the International Slurry Surfacing Association, and verified if these were also suitable for our tests on typical Belgian mixtures. So for consistency, we have the European test methods where the fresh mixture is poured in a cone and the radial outflow is measured after the cone is lifted. At the same time, the operator can assess the homogeneity. And here we found that 3 repeated tests are necessary. And after optimizing the test procedure, we obtained a repeatability of 0.6 centimeters. And in this way, we can logically discriminate mixtures with different compositions. As an example, here we see how the outflow decreases at higher temperature and increases when more water is added to the mix. So this is a very simple but useful test to optimize the mix for consistency. And it was also verified in the field that an outflow of 2 to 3 centimeters corresponds to an adequate consistency. For cohesion, we have this test method in which a rubber stamp is pressed on the test sample with a constant pressure while applying a torque to induce shear stresses on the surface. 4 samples are prepared simultaneously in a special mold, and these samples are then tested one by one at different times, enabling to assess the cohesion buildup as function of time. This test is also repeated 3 times to get a more reliable average value, and for the average of 3 results, we determined a repeatability limit of 0.2 Newton meter. The test results depend on the emulsion characteristics, but also on the emulsion aggregate pair and on mix composition. And here again, the ESA specifications provided us with adequate thresholds for the typical Belgian slurries that we have tested. Wearing resistance is then measured on specimen size of a pizza, which are cured and conditioned in water before testing. And then the surface is subjected to wearing by the action of a rubber hose while being submerged in water. In this test, the surface texture has a significant impact since the rubber hose has less grip on a smooth surface, and therefore it's crucial to produce specimens with equal texture, representative of the texture on the road. This has been verified by texture measurements made on job sites with same mix compositions. The repeatability of this test has not yet been determined because of insufficient test data, but it's clear that repeatability is rather poor. So testing at least 3 specimens and discarding specimens with outlying texture is really necessary to improve the repeatability. But still, this test is capable of discriminating mixtures in a logical way. The result is highly sensitive to the amount of emulsion seen in this table and to the emulsion type and the emulsion aggregate interaction. And as for the interpretation, a maximum loss of 540 grams per square meter seems to be adequate. Then I mentioned before that to measure the resistance to bleeding and delamination, we set up our own test methods, which I briefly show here. Resistance to bleeding is measured in the standard European large size device for wheel tracking, but with test conditions adapted to slurry surfacing and combined with texture measurements before and after the test. Resistance to delamination is measured with the layer adhesion measurement instrument, an instrument which BRC has been using with success now for many years to measure interlayer bonding in the lab as well as on site. Because of limited time, I have restricted my presentation to the performance tests on slurries mixtures, but other tests on constituents and on combinations of constituents have also been investigated in a similar way. And here we see 2 tests that we found of particular interest. The test to measure the stability of the emulsion when mixed with cement, and part 7 of the European test series, also known as the shaking abrasion test, to evaluate the compatibility of the emulsion aggregate pair. So as a conclusion, we have established a set of adequate test methods, one for each performance characteristic. Tests have been linked with field performance, and we have determined the repeatability of the test methods. And now we continue to use these tests for research and for improving mix designs. And in this way, we are further promoting and supporting the use of slurry surfacing in Belgium and abroad as part of sustainable road maintenance strategy. I do hope that this presentation has also contributed to this goal, and I thank you very much for your attention.
Excellent presentation. Our next presentation is going to be from Jan Kroll, the new concept of durable flexible subbase with use of deep coal recycling mixtures. Jan Kroll is an associate professor at the Faculty of Civil Engineering at Warsaw University of Technology in Poland. He received his PhD in 2008. During 2010, he was a visiting researcher in Nottingham University. In 2019, he had a position as a visiting professor at the University of Parma in Italy. He has nearly 20 years of experience in asphalt research at the university and in industry. He's a senior member of RILEM. Since 2014, he's a member of the TC of Bitumen in Polish Committee on Standardization in recent years, and now he has carried out numerous research projects in asphalt recycling. He is the editor-in-chief of the oldest Polish magazine for professionals entitled Road Engineering. Start Dr. Kroll's video now, please.
Ladies and gentlemen, dear asphalt friends, it's my pleasure to present to you our experience from the recent research project on sub-base road concepts using deep cold recycling technology. The project was implemented in cooperation of the Warsaw University of Technology Poland and EUROVI Poland company. As you well know, we have two main technologies, cement concrete and asphalt, used for paving roads. In terms of sub-base layer, there is a wide range of technologies with use of recycling materials like RAP. In terms of deep cold recycling technologies, for example, the RILEM organization provides us proper systematic terminology and limits depending on the cement content. For cement treated materials, cement bituminous treated materials, bituminous stabilized materials, and cold mix asphalt technologies. And how it looks in Poland? Generally, we use mixtures called MCA, or mineral cement emulsion mixtures. This technology originally resembled BSM, but over the years has evolved to resemble CBTM technology. This was due to the need to ensure high stiffness of the sub-base layer at the early stage of the construction. And up to 3–4% of cement started to be used, making the layer too stiff. Here you can see the effect of used technology on the side. In the middle, here, you can see the fresh laid mixture looks like a CTM layer without bituminous material. The effect of such over-stiffening of the sub-base often resulted in transverse reflecting cracking of the upper asphaltic layers of the pavement, as you can see on left and right pictures. And now some backgrounds describing evolution of Polish requirements over the years. Please take a look at the original requirement for MCA mixtures, both regarding the total bitumen content and the application of Marshall test at 60 Celsius degree. These requirements imply the flexible nature of the materials. But over the years, the technical requirements followed practice. The effect of this can be seen in current requirements, such as the stiffness modulus after 28 days, which is closer to CBTM technology rather than BSM. Given the above, in cooperation with EUROVI Poland, we decided to develop and implement a new concept of durable and flexible BSM mixtures for sub-base courses. Following the assumption, BSM should be characterized by improved cohesion and the reduced amount of cement, maximum 1% by mass, in contrast to traditionally used MCA mixture in Poland. For tests, we designed a full factorial experimental based on 3 parameters: cement content 1 to 3%, bituminous emulsion content 3, 4,5, and 6%, and type of emulsions. The two first emulsions, the black one, used for research were typical, but the third was experimental based on harder bitumen 50/70, that's blue one. Those full experiment was next reduced to 9 compositions based on the fractional factorial experimental design method. This allows us to reduce the number of tested cases and overall number of specimens. And going to the results, as you can see on the left graph, results are ordered in the group of the same amount of bitumen emulsion and by increasing value of the cement and the cement content, C1, C2, C3. Generally, we can say that statistical analysis shown on the right graph has proven that the cement amount was the most important factor affecting stiffness modulus of the design mixtures. The results allow to state that the influence of the bitumen emulsion content and their type should be investigated on the mixes containing smaller amount of cement, where the dominant role of the active filler in the MCA mixture is reduced. Similar relationships are obtained for indirect tensile strength results. Similar values of ITS were observed for mixtures with the same amount of cement, regardless of the bitumen emulsion content. The largest standard deviation of ITS values were observed for mixtures containing 3% of cement. Statistical analysis shown on right side has also proven that the cement content was the most important factor affecting indirect tensile strength of tested mixtures. And going to conclusion, it could be stated that in cold recycling mixes containing bitumen emulsion and high amount of cement, the hydraulic bonding is considered to be dominant. The use of materials with dominating bituminous bonding allow to reduce the risk of reflecting cracking in pavements. Cement is the major factor affecting tensile strength and stiffness modulus of the MCA mixes. The influence of the amount of type of bitumen emulsion and the properties of the BSM can be fully assessed through the reduction of the cement content and not higher than 1% mixture by mass. Those results came from an early stage of the project. So now I can say that in the next stage of implementation, BSM mixture based on bitumen emulsion were developed, which met the expectation in terms of lower stiffness and higher flexibility. And a maximum of 1% of cement was used for them only as an active filler. So not a cement binder, but active filler. For the end, I would like to acknowledge for Eurovi company for the collaboration. I would like to say thank you for your attention.
Okay, we'll begin with the questions. I think that Dr. Kroll and Joel will be joining us also, Marimar. I seem to have a frozen screen again, so I'm just gonna, I hope everyone can hear me.
Yes, we can hear you.
Okay, thank you. Thank you, Jan. Okay, the first question, and back to Marimar, I'm gonna go back to the last question that you answered because I didn't quite get what type of polymer is used in the PME.
Okay, the question is that the polymer we have used for this type of emulsion is SBS. And we have used, like I said before, a blending between a polymer modified bitumen and a conventional bitumen to produce this polymer modified emulsion. But the
Okay.
polymer
And when you say polymer modified bitumen, are you talking like SBS polymer modified or SBR latex modified?
no, it's SBS in bitumen.
SBS and bitumen. Okay, perfect.
Yes.
Thank you. Okay, thank you. The next question is to Joël. It says, are you considering to edit some national specifications or at least guidance after the study?
Yes, that's absolutely what we intend to do. Now we're not editing standards, of course, but we're going to give recommendations, and we already produced the one part of recommendations, but it was more recommendations on the selection of the type of slurry for a particular application, and then also with the emphasis on the importance of really correctly preparing the surface before applying the slurry. But there will also be a second part of recommendations, which will be more on the importance of mix design.
Okay, and Joël, I will tell you, I had a comment from Francois Chignon about creating some tests that are complementary to tests that are used in the U.S., the classical International Slurry Association test that we use regularly. I think that's a good, so it shows some concert between the U.S. and Europe.
Mm-hmm.
The next question is to Marimar again. Is there any blending between the RA binder and the added binder in the emulsion?
Okay, thank you for this question. Also, I think so. According to the temperature we use for this half warm recycling, is close to 100 degrees. So we ensure to set the rain and ball temperature of each bitumen from RAP. So this must facilitate the mix. I think so.
Okay, great. Thank you. This next question is for Jan. In your investigation, how did you condition specimens before testing? Example given accelerated aging.
Okay, thank you very much for this question. It's really important. For that results which I shown present today, we curing our specimens for 28 days at ambient temperature and in relative air humidity of about 50–60%, but it was only we conditioned that specimen in that way because it was based on our national requirements. But on the next step of our research, we followed by RILEM recommendation. And when we, on the second step, when we consider BSM and cement like an active filler, we changed the conditioning procedure, and we curing specimen at oven at 40 Celsius degree for 72 hours.
Okay.
Okay. Thank you.
Okay. There are no more questions on the Slido board right now, so I think it would be best so we stay on time to move on to the next group of presentations. Thank you, Marimar. Thank you, Joël, and thank you, Jan, for your presentations and participating in the Q&A. The next presentation is going to be presented by Laurence Lapalou from Total Marketing and Services in France. Title of her presentation is going to be Bitumen and Emulsion Properties, an Innovative Shared Approach. Laurence has an engineering degree from the National Institute of Applied Sciences in Lyon, with especially in physical engineering of materials. After she obtained her degree, she achieved her PhD for Total on the rheological properties and rupture mechanics of bituminous binders. She's been working for Total Group for 20 years. Currently, she's the manager of bitumen research team of the Total Research Center near Lyon, and she's involved in CEN TC336/WG1 as the French expert. She's the chair of the French Mirror Group on bituminous binders. With that, we'll begin the next video.
Hello. Thank you for giving us the opportunity to present the results of the collaboration between Colas and Total on the properties of the bitumen emulsions. First, I would like to give you some background elements, and I would like to present the objective of the study. Sometimes the emulsion producers encounters variations of the bitumen emulsion viscosity. These variations are related to the emulsion characteristics, but they may be also related to the bitumen origin. So for this reason, Total as a well-known bitumen supplier and Colas, recognized in the bituminous emulsion fields, were interested in working together on the understanding of the bitumen properties that may impact the viscosity variations of the emulsions. The first step of this study was the sampling of the bitumens. We have collected 49 bitumens paint grade 160-220 over 2 years in different refineries. The bitumen characterization has been made by Total, and for its part, Colas was in charge of the emulsion manufacturing and characterization. In order to maximize the viscosity variations, we have decided to manufacture Bituminous emulsions containing 69% of bitumen and 71% of bitumen. The emulsions were manufactured at lab, and we have manufactured 98 emulsions. More than 2,500 data on bitumens and emulsions were generated, and so that's why we have decided to use a statistical approach to analyze all the data. Regarding the bitumens, the first graph on the left represents the asphaltene contents for the different bitumens coming from the different refineries. You can see that we are able to differentiate the products. For example, bitumen coming from the refinery B contain few asphaltenes. On the opposite, the bitumens coming from the refinery H contain a lot of asphaltenes. The graph on the middle of the slide represents the aromatics content versus the resins content. And we have established that there is a relationship between these two characteristics. And you can see on this graph that the bitumens from the refinery C don't follow the relationship. And you can see also that the bitumens from the refinery A display high content of resins and low content of asphaltenes compared to the other bitumens. If you look at now the graph on the right, it represents the viscosity at 135 degrees Celsius for the bitumens versus the refinery. And you can see that the same bitumen coming from the refinery A display high values of viscosity compared to the other bitumens. So this bitumen descriptive analysis shows that we have observed differences between the bitumens that we have taken into account in this study. We have also performed some interfacial measurements on the bitumens. The graph on the left presents the surface elasticity of the bitumen versus the resin content and their calcium content. On this graph, the blue zone corresponds to the low value of surface elasticity, and the darkest blue zone corresponds to the lowest values of surface elasticity. On the opposite, the red zone corresponds to the high values of surface elasticity, and the brightest red zone corresponds to the highest values of the surface elasticity. You can see on this graph that we are able to differentiate the bitumen. For example, the bitumen coming from the refinery A display low value of surface elasticity, and on the opposite, the bitumen from the refineries E and F display high value of surface elasticity, while bitumen coming from the refinery H display intermediate values of surface elasticity. And if you look at the right bottom of the graph, it corresponds to the highest values of surface elasticity. You can see that it corresponds also to the lowest resins and calcium content. So the surface elasticity has been found to be in inverse proportion to the calcium and the resin content of the bitumen. This graph displays different emulsion characteristics that are the medium diameter, the sieve residue, the pH, the efflux time, the dynamic viscosity, and the breaking index. First, we didn't observe high values of viscosity and high important variation of this viscosity. Only few values of efflux time are over 40 seconds. The statistical analysis has highlighted that some characteristics that are the pH, the efflux time, and the dynamic viscosity could be described according to a normal distribution law. And the statistical analysis has also highlighted that three variables of the emulsions, that are the dynamic viscosity, the pH, and the medium diameter, can summarize the measures carried out on the emulsion. So that's why for the next slide, I will be focused on the pH and on the dynamic viscosity. We have used a PLS model to establish relationship between the emulsion characteristic versus the bitumen properties. And you can see on the graph the pH variability and the dynamic viscosity variability versus the bitumen's variables. A bitumen variable is considered as statistically important or statistically relevant if the blue bar exceeds the red dotted line. And the higher the blue bar, the greater the importance of this bitumen variable. If you look at the graph on the left, you can observe that 71% of the pH variability is linked to the bitumen. And it is linked to the element contents, to the total basic number of the bitumen, to the Sahara fraction, the penetration, and the bitumen viscosity at 135 degrees Celsius. The other 29% of the pH variability are linked to other factors, such as the experimental conditions to produce the emulsion. If you look at now the graph on the right, representing the dynamic viscosity, you can see that 78% of the emulsion viscosity is linked to the bitumen variables. And in this case, you can see that the bitumen content of the emulsion is far away the most important parameter impacting the dynamic viscosity of the emulsion. We have also used a PLS model to represent all the emulsion characteristics versus all the bitumen properties. In this case, you can see that the quality of the model is poor. Only 54% of the emulsion's characteristic variability is linked to the bitumen variables. The other 46% of the variability of the emulsion properties are linked to other parameters, such as the experimental conditions of the emulsion manufacturing. And the bitumen content of the emulsion is by far the most important parameter impacting the properties of the emulsions. In conclusion, we have collected 49 bitumens for this study, and we have manufactured and completely characterized 98 emulsions. We have generated more than 2,500 data, and we have used an analysis, a statistical analysis to analyze all this data. The bitumen analysis shows differences in properties and composition between the different bitumens, depending on their resource point. We didn't observe high viscosity variations for the emulsions that were produced at lab compared to the industrial production. The statistical analysis has highlighted that the bitumen variability can explain only a part of the emulsion's properties variability, and the bitumen content has been emphasized as the main factor. But there are also other factors impacting the emulsion properties and especially the emulsion viscosity that are the experimental conditions to produce these emulsions. I thank you for your attention.
Excellent presentation. Thank you, Laurence. Our next presentation is a new generation of semi-warm emulsion asphalt concrete feedback and field of use. This is being presented by Frédéric Deluc from Colas, Southwest France. And Frédéric became the materials interface engineer in Lyon, France recently, and he started work with Colas in 2000 as an engineer in binder and bituminous emulsions on cold mix, and he at Colas Southwest. He's worked in the development of different cold mix processes and recycling, in-place recycling to regenerate sub-base layers, and now his job consists of managing a team of laboratory technicians and managers and to technically assist the contract manager.
Warm and hot asphalt mixes are used for all levels of traffic. Cold asphalt emulsion mixes are used only in the case of low and medium traffic levels. The desire to improve emulsion mixes so they can be used under slightly more demanding conditions has led to the development of semi-warm asphalt emulsion. In this presentation, I will begin by defining what is meant by semi-warm asphalt emulsion mixes, then give an account of the processes used to manufacture them and their performance, and finally describe two projects where they have been used them in France. Semi-warm emulsion mixes are mixes whose temperature is below 19 degrees. They can be used in variety of thicknesses: thick, thin, very thin. They can be laid in sub-base and rod-base layers and wearing courses in the context of new construction or maintenance. Their grading ranges from 0.6 to 0.18 mm, depending on the application. The aggregates and emulsion comply with the applicable French standards. One of the advantages of this product is that it can include recycled asphalt pavement in proportion of between 0 to 100%. Laying is conducted with conventional equipment, pavers, and drum rod rollers. There are currently two manufacturing processes, which I shall now describe. The first consists of manufacturing a cold emulsion mix from sand, aggregate, rape, and emulsion. This mixture is then heated in a warming tube which produces the semi-warm mix by raising the temperature to between 50 and 19 degrees. The photo on the left of this slide shows the cold manufacturing process, and the photo on the right shows the warming of the emulsion mix in the tube. The second process consists of heating the aggregate in a dryer drum. This heated aggregate is then transported to the cold manufacturing plant. It is then mixed with wrap sand at ambient temperature and emulsion in order to manufacture the semi-warm mix, which is also at temperature of between 50 and 19 degrees. The photo on the left of the slide shows a dryer drum which dries and heats the aggregate. The photo on the right shows the entire system that takes the hot aggregate to the cold manufacturing plant. We shall now discuss the mechanical performance of these semi-Rom emulsion mixes. In order to compare the two processes, we have recovered industrial samples of each manufactured with the same raw materials and using the same mix design. The latter is shown in the table. As can be seen, for this experiment, we used 55% of RAP. The next table shows the classical granular blend for this type of mix. On this slide, we have summarized the performance results of the two processes. In terms of coating, more than 19% of the surface of the aggregate is coated by the asphalt. In the case of water susceptibility, it can seem as the two processes are virtually identical. For compactability, both processes provide voice contents which comply with the specification in the current French standard for emulsion mixes, whatever the number of generation, 25, 40, or 60. This clearly confirms that the material can be used in different thicknesses, thick, thin, or very thin. With regard to rotting, the two processes are identical, with 13% of rotting after 3,000 cycles. Finally, the elasticity moduli we measured are fairly low and typical of emulsion mixes, with values of between 1,500 and 5,000 MPa, depending on the aging conditions. First, 14 days at 35 degrees. Second, 14 days outside. Third, core samples taken from the site after 6 months. 14 days at 35 degrees plus 6 months at 18 degrees. And the last, 14 days outside plus 6 months outside. We shall now describe this product's scope of use. As we have seen in the introduction, they can be used in new pavements and for the maintenance of existing roads, in particular those subject to deformation. In terms of traffic, we can state without any hesitation that they can withstand traffic levels of up to 150 heavy goods vehicles per day and per direction. They are particularly appropriate for pavements with high deflection, on which hot mixes are not recommended. Like emulsion mixes, semi-Rom mixes are used outside urban areas, but they can also be used on through town roads due to their faster cohesion build-up. We shall now consider the two construction projects. The first process, known as ECOMAC First, was laid on a 6 kilometer length of road on the RD 35 County Road in France. The level of traffic of this pavement is 25 to 40 AGVs per day and per direction. On most of this site, the semi-Rom emulsion mix contained 55% of RAP, but two test sections were also laid with 75% and 100% of RAP. The spread rate was 85 kilograms per square meter. Monitoring was conducted for 3 years, and it can be seen on the table below that after this period, the macrotexture was still very good, whatever the wrap content. It should be noted that these values are better than the French specification for emulsion mixes at acceptance. This slide shows the work in question with laying carried out with a paver and a drum rod roller, and also the appearance of the laid product. The second process, known as ECOMACT second, was laid over a 2-year period on 19-kilometer lengths of road on the RD 21 country road in France. The level of traffic of this pavement is 85 HDVAs per day and per direction. The Semi-Rom mix contained 30% of wrap and was laid with a sprayed rate of between 70 and 75 kilograms per square meter. We observed that the mean macrotexture was 0.75 millimeter with a standard deviation of 0.09. These values are well able to stand comparison with conventional thin hot mixes, such as the French type A very thin asphalt concrete. This project resulted in greatly improved pavement ride quality. As you can see in the table, the longitudinal profile analyzer level results have increased by almost 2 units. The next slide shows some photos of laying process for this project, which used a paver and a drum rod roller. Aesthetically, the pavement is very similar to a hot mix. Thank you for attention.
Our next presentation is going to be Revetment Special Combined, or the French Cape Seal, and this is going to be presented by Claude Georgie of Eiffage Infrastructures in France. Claude is he began his work he has worked in the road industry for nearly 25 years. He's a chemical engineer, completing his master's degree in quality management at ENSAM in Paris in 1998. He started as a young engineer with Eiffage in the central laboratory. He left the company to pursue some other opportunities with Probinord in microsurfacing as leader in microsurfacing pavements. And in 2006 to 2014, he worked for Mead-Westvaco. He's currently back with Eiffage, and he is the deputy technical manager specializing in bitumen binders and bitumen emulsion techniques. His mission is to have expanded development of emulsion-based techniques for the company, as well as one of the company's main representatives of the French road industry in the Union Route de France. With that, please start the next video. Thank you.
Good morning. My name is Claude Georgie. I work for Eiffage, and I'm going to tell you about combined layer coatings, the French development of the Cape Seal technique. This presentation was written together with Sabine Lebec from Eurovia and Christophe Priez from Colas. In a context of economic crisis and constrained budgets, France has been questioning maintenance techniques to optimize cost and performance. This diagram shows that preventive maintenance maintains the integrity of the road for a lesser cost than structural rehabilitation if maintenance is postponed to a degree where the structure of the road is damaged. The Cape Seal is a surface treatment used when pavement damage is too important to be treated with microsurfacing or surface dressing alone. This technique is composed of the following elements. A first layer of a single 610 or 1040 millimeter chip seal with an open mesh of 80% is applied. A second layer, consisting of microsurfacing, will fill the gap between the aggregates of the previous chip seal to ensure sealing action. This combined layer coating makes it possible to obtain a waterproofing of the pavement to avoid the phenomenon of rejection and to guarantee microtexture over time. Indeed, the initial microtexture of the microsurfacing layer can be relayed after wear of it by the emerging microtexture of the gravel head of the surface dressing layer. The advantage of this technique compared to traditional surface treatment is given by this table. The residual binder content of a combined layer pavement compared to either a dual layer surface dressing or dual layer microsurfacing is higher. This high surface rate of binder partly explains the great interest of this technique for waterproofing on crack support. Specific points, though, need to be considered, such as bleeding phenomenon that can appear on certain cases. The different advantages of the technique can be summarized in this slide. As a surface treatment, combined layers will restore the grip and ensure the waterproofing of the road, but it will also stop the evolution of raveling and extend the life expectancy of the roadway. These different properties were used in 3 different case scenarios with different environments and constraints. First, the Mont Ventoux in the south of France. A section of 30,000 square meters was applied on the RT 974. This road is access to the ski resort of the Mont Serein at 1,400 meters of altitude. The climatology of this road is also very atypical, with temperatures that can be hot in the summer, but also very strongly negative in the winter at the summit, with violent snowfalls that require the passage of a snowplow. This pavement was degraded mainly by surface cracking related to the aging of the pavement. Combined layers was proposed as an original solution with the double interest of being both economical and to perfectly meet the need of the department council, sealing the road while ensuring a sufficient level of adherence. The choice was made of a first application of a latex modified emulsion at 1.7 kilograms per square meters with a 610 millimeter sand lime gravel at 6 to 7 liters per square meters application rate. Then a microsurfacing layer was applied at 18 kilograms per square meters. The microsurfacing layer was applied about 2 hours after the first layer. The use of combined layers coatings has also been validated on highways, as it happened on the I-33 highway, for instance, in the north of France between Lille and Valenciennes. The average daily traffic was greater than 2,000 trucks per day. It was a semi-rigid structure covered with a 14 centimeter thick bituminous product and a weighing course dating from 2004 consisting of a thick 0.10 millimeter bituminous mix designed with a multigrade binder for a total thickness of 7 centimeters. The roadway has a state of generalized thermal cracking with locally an aggravation of the surface degradation, but the structural integrity of the pavement was good. The job site took place in 2013. For 6 years, the pavement was observed by performing visual surveys, microtexture measurement, CFL and CF2 measurement, as well as noise emissions. So far, assessment is extremely positive, with no structural degradation, and the surface coating that has retained all its integrity. Finally, a third job site was done on the RN2 on the National Road 2 in France, between Soissons and Laon, in the northeast of France. The support of very thin asphalt mix dating from 2006 mainly shows cracks and localized steering areas. Localized ripples and cracked pinching were required in the most degraded areas before combined layers was carried out. 33,000 square meters were applied on the RN2. The traffic was very heavy, about more than 6,000 vehicles per day, 15% of which being heavy trucks. We then adapted the dosages to this traffic and applied a surface tracing consisting of 1.75 kilograms per square meter of emulsion and 5 to 6 liters per square meter of a 6-ton aggregate. Then we applied a microsurfacing pavement at the rate of 18 grams per square meter. Those 3 different job sites on very different environments and configurations shows the flexibility and performances of the technique, offering a new tool in the available portfolio of solutions available for the surface treatment of damaged pavement. More generally, since introduction in France in the years 2010, 2011, the monitoring of the first sites makes it possible to highlight the potential of these combined layer coatings, which present a technical and economical interest for all road networks. One of the most sensitive points of the realization, though, is the mastery of the sequencing between the workshop of application of the surface dressing and the one of the cold microsurfacing layer. Indeed, circulation of vehicles on the first layer is strongly discouraged. On the other hand, the rise in cohesion of the binder of the microsurfacing layer must be enough to receive the installation workshop of the microsurfacing layer. The design must be as short as possible, but sufficient. Rapidly, this technique has been accepted all over the country as one of the most cost-effective maintenance techniques available. eDream, the Institute for Roads, Streets, and Infrastructures for Mobility, federates public and private actors in the field of transport infrastructure. As an exchange platform, eDreams aims to provide answers to its main members' issues, publishing reference documents and promoting French knowledge internationally. In 2010, the eDream organization wrote a technical note to introduce, promote, and give the best practices for the application of this combined layer technique. Thank you very much for listening, and please do not hesitate if you have any questions.
Thank you, Claude. And I'll ask Laurence, Frederick, and Claude to join me on video for the Q&A. And I still seem to be having an issue with my my camera, so we'll begin with the Q&A. The first question is for Laurence. Are there variations in bitumen properties you found greater now than we would have been, say, 10 years ago? If so, what are the main reasons for this, in your opinion? No, we can't hear you. I'll move on to the next question. You see if you can get your microphone. We'll check it again in just a moment. If that's okay with, that's a little better. No.
I can write my answer in the chat.
Okay, and I'll go ahead and proceed with the other questions. Thank you. Frederick, could you please comment on the benefits of this technique compared to cold mixes? Do you think virgin binder and binder coming from RAP homogenize partially at this temperature?
Okay, thank you for the question. I think there is a blend between virgin binder and binder coming from RAP because of the temperature. We are nearly from 18 to 19 degrees, so I can think that the blend is a mix. And the advantages of the product of these products compared to cold mixes are essentially the reduced sensitivity of the product, like cold mix, because of the good cohesion quickly.
Okay. Claude, there is a question for you concerning
the workability.
Yes, I was trying to find it. I moved past it.
The workability is obtained by the water in the product and with the temperature. Sometimes we can use solvent with high rate of RAP, but usually the workability is done by water and temperature of the product.
Okay, great.
And the emulsion is a cationic emulsion at 60% of bitumen, pure bitumen.
Okay, great. Thank you, Frederick. Okay, Claude, from Jean-Claude Roffet, he says, how large is the use per year of combined layers of Cape Seal in France as % of the market penetration compared to microsurfacing treatment?
Yes, but to be honest, I don't really know. Sorry, I would say it's quite much less than microsurfacing, but I'm not going to give figures. I have a figure in mind, but I would say it's still it's not a new technique, but it's still in progress and it's getting more and more used every year in France. But let's say we're doing maybe 40 million square meters of micro in France, and maybe I don't know, 2 or 3 million square meters of Cape Seal, I would say.
Okay, thank you, Claude. And going back to the previous question that we asked Laurence, which was a variation of bitumen properties found greater now than would have been, say, 10 years ago. If so, what are the reasons in her opinion? Laurence responded, I don't think the variations in bituminous properties are greater than they would have been some years ago. We have collected 49 bitumens in the study from different refineries. We have observed differences in properties and compositions, but the statistical analysis has shown that they are second order compared to the bitumen content of the emulsion. I think this next question is for Frederick again, and it says, how do you manage to get accepted? Oh, that's the one you've already answered. Sorry about that, Frederick. I'll switch to this question, a question for Claude. An innovative approach with obvious time savings benefits. How does the process compare regarding cost and other parameters to other existing technologies?
Yes, okay. Well, basically, it will be a little bit more expensive than a double layer microsurfacing, but it also the price also depends on the organization of the job site. Basically, you have really to to have a good interaction between the two workshops, the surface tracing and the microsurfacing. So if you can optimize and have a good organization on the job site, it will be about the cost of a double layer microsurfacing. If you have a different organization and you cannot be as fast, it will be a little bit more expensive, but that's roughly the cost of the technique, and it really depends of the good organization and the good timing between the two techniques.
Okay. Lawrence, I'm gonna ask two questions here and let you answer in the chat. They're actually they kind of go with each other, I think. The first question is, the total and COLA study is very comprehensive. Is there any intention to do more data assessment and draw new inferences? And then the other question is, does the chemical composition of the bitumen affect the emulsion properties such as storage stability and curing time? If you want to put that in the chat, we only have about 4 minutes left. If I get to it, I'll get back and give the answer. Thank you, Lawrence. The other question I had for Frederick was, that's the same one of our, ECOMAC, what a good experience having more than 10 years of experience. Why not being used? Why is it not being used on a larger scale? Semi-warm mixes based on emulsion are the future to comply with climate change, reducing emissions and big path to decarbonizations. We should widely embrace this technique. I guess he's asking why you think it's not used on a larger scale.
I think in the future we will use this product for high-level traffic because the customer likes this product because of use of high rate of wrap. It is uneconomical in terms of use of energy and non-renewable resources, and an impressive environment footprint.
Okay, thank you. With that, like I said, we were approaching the end of the session. We do have a comment from one of our viewers. This is a very good session. Bitumen Emulsions is an incredible product to maintain the road network as soon as it's employed at the right time and the right road with the most efficient technique. I think that is a very good comment, so that's why I wanted to mention it. I don't see other questions here that we have time to. Well, let's try this one for Claude. I don't think I've asked who is. An innovative approach with obvious time-saving benefits. How does this process compare with regard to cost parameters to other existing techniques? Did I ask you that already, Claude?
I think so, yeah.
Okay, start, then I'll go on. In fact, we only have a minute left, so with that, I'll say we'll draw this session to a close, and I'd like to thank our presenters. I'd like to thank Marmar, Joel, Jan, Lawrence, Frederick, and Claude. I think you all did very good presentations on very good topics, and we really appreciate you, and we're glad we had a session on emulsions for this 2021 E&E Congress. Sorry about the glitches in hardware, but like I said to the folks from KNS, this is basically just a ghost in the machine. I checked everything last night; it was working fine, but it just seems to be glitching today. In fact, you can't see it, but I'm looking at a picture of Marmar, and it says her name is Frederick DeLuc. So I know that's nothing to do with what's going on. But I thank everyone. Enjoy the rest of your day, and we'll see you hopefully in person at the next E&E Congress.